Hello and welcome to a time displacement Slitscan coding challenge. This video is part of the Support P5 campaign, Adopt a Function series. Thank you to Tim Rodenbroker who adopted the copy function for this video. If you're not familiar with Tim's work, he teaches all about creative coding on his website. You can see beautiful examples of what he's done with the copy function on his Instagram. He's got an upcoming course all about the copy function, and I would certainly encourage you to subscribe to his Patreon to get access to all of his courses. I've already finished recording this coding challenge. What you're seeing here is the end result of the video. I'm going to start by just what is the copy function? What arguments does it take? How does it work? How can it be used to create a Slitscan effect? And from there, move on to warping time and space itself. Enjoy! I'm going to begin this exploration of the copy function with just this basic processing sketch, one red circle right there in the top left corner. At its core, the copy function does one thing. It takes a rectangle of pixels, this is known as the source, and copies them to another rectangle of pixels known as the destination. To execute the process, call the copy function with 8 arguments. The x, y, width, and height of the source rectangle, the x, y being in the top left, the width and height of that rectangle, and then the x, y, width, and height of the destination rectangle. Once again, the x, y being in the top left, and then the width and height. Let's see this in action. I'm going to attempt to copy the top left quadrant of the canvas to the bottom right. There we go. It looks like I just called the circle function again for a different location, but I have not. I'm actually just copying the pixels from a rectangular portion of the canvas to another one. What is especially exciting about using the copy function is the destination, the dimensions of the destination rectangle do not have to match the dimensions of the source one. So I also have the opportunity to stretch and skew and twist that original image. Here, I'm just setting the width and height of the destination rectangle according to the mouse X and mouse Y location. This isn't a particularly engaging example. If I really just wanted to draw multiple shapes and kind of skew them, I would just keep using circle and ellipse and change the colors and the dimensions of the actual geometry that I'm drawing. While I do think there is lots of potential for what you could do with generated graphics and the copy function, what I'm going to move to demonstrating now is what happens if I start to use the copy function with an image that I'm loading or perhaps even a real-time video. In this particular sketch, I've got an image of the Choo Choo Bot character in the data directory. Now I can load the image from the file and display the image using the image function. Now what happens if I put back in the copy function? Here we see the top left portion of the image copied and overlaid onto the image itself. This admittedly though is a little bit strange. Here I am taking the image, drawing it to the canvas so that I can copy a portion of it to also draw it to the canvas. The copy function can take an additional argument right up front, the source image itself. So rather than draw the bot image, I can just place a reference to the bot image as the first argument in copy, and there we go. Now I'm copying just that one section of the image to the same spot in this window. This immediately opens up a lot of possibilities. For example, what if I draw the image by copying a sequence of slices? So this looks like I'm just drawing the image as it was before, but I'm not. I'm displaying it as 40 slices, each of a width of 10 pixels. I'll put a rectangle overlay just so you can see it. There. Now you can see the scale and size of each of those slices. So there's really no reason why I couldn't take a different part of the image and display it in a different place. Shuffle up the slices. Here, the moment I'm about to copy from the image, I pick a random X location to copy from. I'm still going to put them in their linear sequence, but the source will be random. I've added no loop so that it just does it once. Now you can see I've completely mixed up the image. Taking away that rectangular overlay, and there you go. Here's an exercise for you. Could you shuffle up an image in a grid rather than, instead of just a horizontal slices, a checkerboard pattern? I would like to take this in a different direction and just explore some algorithmic visual possibilities. Let's start by adding a sine wave pattern to the location I'm copying from. If sine waves are unfamiliar to you, it's simple harmonic oscillating motion. I'll refer you to my Nature of Code video series all about these wave patterns. I'm going to use the variable name sx for the source x. Again, if I just use x directly from the loop, we get the image as is. What if I were to offset the source x location by some counter variable? X plus counter. There is a built-in frame count variable in processing, but I'm putting my own variable in here because I'm going to start to do more with it once I get to harmonic motion. Amazingly enough, it's just sliding the image because I'm moving where I'm copying from. So what if I were to introduce the modulo operator? The modulo operator takes the remainder of division. So numbers, as they increment past the width of the window, will cycle back to 0 and again and again. Sort of little blinking, accidental blinking effect as it's kind of working with those end pixels a little by little. If I were to use the width itself as my incrementation variable, then I will get rid of that little flickery effect. Of course, it's moving much faster because it's going by 10 pixels each time. So what if, though, instead of offsetting by just a counter variable that's going up by 1 and 1 and 1, what if I offset by some variable amount that's smoothly oscillating up and down? Let's change counter to angle. Angle plus equal some small amount. I'm going to make a separate offset variable, which is sine of that angle. I'm going to map that value. The result of the sine function is between -1 and 1. And I want to offset it by some amount of the width of the image. Now, because I'm dealing with pixels, it's important that I stick with integers because there's no sub-pixel values. There's no pixel 1.5, 1.6. So I will also convert that offset to an integer. And let's see what we get. Now it's shaking back and forth. I think I've really got to deal with the fact that there's a specific number of columns here. Even though I have the full width of pixels, I only have 40 slices because each one is width of 10. And I'll call those columns. The number of columns is the total width of our image divided by the width of each slice. Now I'm really looking to map the offset not to the total number of pixels, but the total number of columns. And then to find that source location, I can expand by the width. There we go. Back and forth, back and forth. This is getting somewhere, I think. I mean, I haven't actually done this before. I'm doing this just in real time right now as I'm recording this video. Let me slow it down a little bit. There we go. It looks kind of stuttery because it's actually moving by 10 pixels each time. So what's happening here? I have a sine wave. This motion up and down, you can think of it as, I'll use a train whistle here, as a slider sliding back and forth across the image. So right now, every slice is sliding back and forth at the same speed. But what if some slices slide more quickly? Or some slices slide more slowly? Then, wouldn't I start to see the image break itself apart, put itself back together as the slices become out of sync from each other? One way to approach this would just be to multiply the angle by some factor. So x is going between 0 and width. And why don't I multiply that angle by some amount between like 0.1 and 2? So I'm shrinking it or doubling it. Multiply by factor. Well, I'm not really sure I knew what was going to happen there, but we're starting to see the possibilities here. At some point, I would imagine it's going to put itself back together. I'm having to restrain myself right now because I want to keep going with this. I think there's probably more clever ways I could think about offsetting the different wave patterns, thinking about the slices as horizontal rather than vertical. Maybe I would use Perlin noise or some other kind of algorithm. Please explore those things. And certainly the source image that you choose to work with will make a huge difference in what kinds of visual outcomes you get. But the title of this video is Slitscan, and what I want to move towards doing is looking at what happens when I start to work with a moving image, a video image, something that is not static like the Choo Choo Bot. So let me quickly replace the loaded PNG image with live video. I've completely forgotten how to do capture in processing. There we go. And certainly I could work with code in a flexible way where the width and height of my canvas doesn't necessarily match the source image. Everything's going to be a lot easier if they do match, so I'm going to match them. It's not create capture. New capture. Oh, this. I need the this. No dot, just this. So here I am using processing. So first of all, I've got to give permission on a Mac at least for processing to have access to the camera. And then because I do all sorts of crazy things with this computer, I'm getting the Open Broadcast Studio virtual camera into processing, which I don't want. I want my webcam. So let me look at all of the cameras that I have connected. And I can see here, 0 is the OBS virtual camera, 1 is the FaceTime HD camera, the built-in webcam. There we go. Whoa! Glitchy, glitchy, glitchy. So I was being lazy here. I just want to put cam.read. Just read from the camera while you're looping through draw. That's not really the proper way to do this. I should be writing the actual capture event, which is triggered whenever there is a new image ready from the camera. And there we go. Don't ask me what all this red is down here. I have a feeling I've got some weird wonky settings on my computer, so I'm just going to ignore that for right now. It's working. Now there's no reason why I can't just put in my code from before, but replace the bot image with the live camera. And there we go. Woo, lots and lots of fun to be had. I've actually done quite a bit of this in a video that I made years ago demonstrating Slitscan in P5.js. And in that video, I referred to this article, this catalog of video artworks and research about Slitscan photography from Golan Levin. I would really encourage you to check it out and look at all of the historical precursors to what we do today with computational media, whether it's film, photography, analog video. And additionally, since I made this so long ago, I would love to hear from you in the comments. What are your favorite historical examples of Slitscan photography, current artists working with these kinds of techniques? I would love to know all about them. But I just want to take a minute to demonstrate how Slitscan works in processing. And of course, I'll also include P5.js code as well. So we're still working with the same core concept of having a source image and a destination image. In this case, the source image is my webcam, and the destination image is the processing window. The way Slitscan was performed with real film, analog film, take that film and expose it while sliding it past a slit-shaped aperture. In other words, this is our view of the camera. Here is maybe that slit. We're able to look at just one slice of pixels in this digital image. And then this is like our film, but this doesn't slide. Rather, we'll take those pixels and put them here, and then the next frame we'll put them here, sliding this slice essentially across the destination. How do we do that? The copy function. Copy the pixels from a slice, put them here, 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 put them here. When we get to the end, go back to the beginning. So let's keep that width of 10. Have a global variable called x, and copy. Really, I could choose any slice, but I think it's going to be most convenient if I take the middle slice of the camera, and that's what I'm always copying. So the middle is width divided by 2 minus the width of the slice divided by 2. And always copy it to that x position. I don't need columns anymore. So now you can see that's that slice of the middle of the camera. It's just always being copied to the leftmost part of the canvas. But what if every frame I move that slice over by a pixel? Well, now you can see it's moving. I forgot I'm erasing the background every time. So I'm just actually seeing that slice move across. And I think I want to match it with the actual width, so move it by the width of the slice itself. We'll see that again. It'll move much more quickly now. Let's stop drawing the background just once in setup. And there you go. You can see I've like smeared myself all the way across the image. But it got to the end, and where did it go? So I'm going to try, if I stay very, very still, we see that one slice being duplicated. Of course, my mouth is moving. If I could move at the exact speed, then I can practically get an image of myself. I could be in it twice by moving back and forth. There's a lot of possibilities here. And of course, I can reduce the width itself as well. Let's put it down to 2 pixels. This already, I think, gives you a lot to work with, but I don't want to stop here because I think there's 2 things I could add that will really expand the creative possibilities of this particular demonstration. The first is, what if instead of copying the source pixels to the destination processing window itself, I had an interim step? What if I had a PImage object itself where I could take those pixels into it and then I could draw that PImage into the destination? What that would allow me to do is use things like translate and rotate. So what if I wanted that slice to appear askew? What if I wanted to draw my Slitscan slices in a radial pattern? I'm going to create a PImage called slice. It's an RGB image with the dimensions of the slice itself. We know the copy function can take as its first argument that image source. But where do I put the destination if the destination is not the processing window itself? Well, it turns out I can call copy as a method on a PImage object, a destination PImage. Slice.copy. Now, X is no longer the location into where I'm copying it. I'm always just copying it to the entire slice. But X is the location where I'm drawing what I've copied. This is exactly what I had before, but guess what I can do now? Translate to the center of the window, draw the image from that center, and rotate by some angle. What should that angle be? Let's take X, which has a range of 0 to the width of the image, and map that to 0 to 2 pi radians, a full rotation around a circle. Oh, I'm missing the range of angle goes from 0 to 2 pi, not just 2 pi. And look at that. There's my Slitscan. Now, I'm getting this kind of moire pattern effect because, the pixels in the center of that rotation are very close to each other, and then they're getting further and further apart as the line extends out from the center. So I actually might want to just kind of work with that angular rotation separately from this X value itself. So I'm just going to make my own angle variable started at 0 and kind of arbitrarily just pick an incrementation value and try to fine tune it trial and error style. That's a little bit better. Maybe I could also just have the width be much bigger of what I'm copying. And there we go. You can see there's no kind of missing pixels anymore that I made it wider, and I can kind of have that spin around this rotational path. So that's one thing that allows me a lot more possibilities, copying the pixels into its own PImage object. But once I've copied it into a PImage object, and then I go to the next frame and copy it again, I lost the previous one. What would happen if I actually stored an array of slices? What if I kept track of the history of slices and cycled them around the screen in various ways. By doing this, I'm going to get a time displacement-like effect. Let's see what that looks like. I'm about to try this. Let me go back to just the slices themselves without being rotated, and I'll make them horizontal this time. Don't worry, I'm saving all of the versions of the code that I'm writing, and you'll find all of them on the webpage associated with this video, which is linked in the description below. Okay, I think I've got this right. I've gone back to taking a horizontal slice from the camera, copying it into the slice PImage, drawing that slice PImage at a different Y location, going from top to bottom. Slice is, oops. I have to change the dimensions of the slice itself. Oh, I did something wrong here. I was copying from the bottom. I need to copy from the middle, height divided by 2. What is going on? Width H to 0. Oh, no, I forgot. I'm copying to the image. So I also have to copy it to 0, 0 of the image. Y is where I'm drawing it. There we go. Now I have exactly what I had before. I have a vertical slit scan of just the video image. I now want to make my slice into an array of slices. Slices is a new PImage array of height divided by H. That's the number of images I need for all the slices. Each slice is a new blank PImage. I then need a counter to count through which slice do I want to put the new image in. We'll call that slice index. Slices slice index dot copy. And let's just display all of them. Slices index I at I times H. Oh, well, it's working, but I'm not increasing the index. So let's say slice index plus plus. Same as what I had before. Of course, when I get to the bottom, it goes out of bounds. So I can use the modulo operator with the length of the array. And there we go. Now, you're probably asking yourself, and I'm asking myself the same question. I don't get it. You went through all this extra work to create this array so that you can copy the slice to, let me draw what I'm doing here. I have my source video where I am taking a middle section of pixels. I am copying it to an array called slices, where it goes here, and then it goes here, and then it goes here, it goes here. This is the slice index, which is changing every frame. And then this entire array just gets drawn right into the destination image. Basically, I've engineered a lot of extra memory to store the history of the images just to create the exact original slit scan effect. However, what this happens to be, beyond just all the images of a current view of the slit scan, it happens to be a history of the most recent slices. There's no reason why I couldn't start to play back that history in each one of these slices. To do that, I just need another offset. Offset is 0. Slices I plus offset. Where am I? That's a time offset. Where am I in the history? Offset plus plus. Now this is getting a little bit wonky. If that offset starts to increase, it's going to also increase past the end of the array. So I'm going to make a variable called current index, which is I plus offset modulus the length of the array. And let's see what happens. Closer to what I was thinking. So I went off in a direction that was really making sense to me. And then I realized this is not exactly what I'm looking to do. I kind of like this effect. It's sort of sliding that Slitscan effect along, and it makes it seem much more continuous as opposed to that it gets to the end and it just starts over. So I think there actually is quite a bit to explore here. But what I actually want to do is have a history of the full frame so that I can take different slices from different points in time. So I'm going to double back a little bit and implement that. So I'm going to call this PImage array history. You know, it's up to me to choose how long I want that history to be, but I think the total number of slices actually kind of makes sense. Remember, it's the full image. Now I'm actually copying directly to the window. The difference is I'm copying from a different moment in time, not just the current video. Copy from the history itself, from its corresponding Y position. The Y position being I times H. I'm still going to need that offset, so hold on to your horses. Oh, wait. I've got to save that. I just made blank images in the history. I'm like, what am I doing here? Aha. History index is 0. Every time I get a new frame from the camera, copy the entire image into it. Why do I only have one slice? Oh, I forgot to increase the history index. Okay, then I've got to copy it into the next spot. Now I'm back. I'm back to that original Slitscan effect. But in memory is not just those slices, but the full image. So I can start to move through time within each slice. That's where the offset comes in. Offset equals 0, offset plus plus, current index equals I plus offset modulus history.length. And there we go. There's the time displacement I was looking for. So I'm going to stand very, very still. And with standing very, very still, nothing's really changing except for my mouth. If I just move my head to the left and the right, I start to get that wiggle effect. Now you can start to imagine what happens if you take this effect and do it in a radial pattern, in a vertical pattern, in all sorts of other ways, in a grid. So many possibilities. Finally, I have the Funhouse Mirror animated time displacement sketch that I imagined creating at the beginning of this video. Thank you so much for sticking with me. Oh, I hope you make your own version of this. I'm so excited to see the results of what I couldn't possibly imagine in my mind right now. Thank you so much to Tim Rodenbroker for your generous donation to the Processing Foundation and for inspiring the contents of this video. Check out his website, all of his courses. He's got a new one coming up all about the copy function that I'm sure will explode the possibilities way beyond whatever I did in this video. And I will see you once again on the coding train as we journey along through the creative coding landscape. Is that it? Did I almost get a catchphrase? No.